Hello again, everyone. Dr. Tom McNamara back for our course in Prep for College Math. This video relates to section 1.7 of our book concerning prime factors and exponents. So up to this point, we've been talking about the operations of arithmetic, namely addition, subtraction, multiplication, and division. We've also worked on some problems that we can solve using those operations. So far, we have worked on putting numbers together, okay? But if you're going to do work in mathematics, not only do you need to be able to put things together, you need to be able to take them apart. And that's what factoring is about. So let me go ahead and just give you some examples of factorings, okay? So find the factors of each. Okay, now you might be familiar with this word here. We've actually seen it before in our section on multiplication. So in a equation like this, okay, 6 times 5 equals 30. These guys on the left are called factors. Okay, the 6 and the 5 are both called factors, and the 30 is called the product. So when we were working on multiplication, we would have the factors and try to find the product. Now we're going to go backwards. We're going to find the factors of these numbers here. Okay, let's start with a pretty easy example, 6. Okay, now when you're listing factors of a given number, you never find just one factor. Every factor always has a companion. Now, 1 is a factor of everything, right? Because we can write 6 as 1 times 6. Okay, that's a property of 1. So what I usually do, I give myself a little space. We found a factor. 1 is a factor, 6 is also a factor. 6 is an even number. That means 2 is a factor. And the companion factor with 2 is 3. Now 6 is a pretty small number, so these are all my factors. 1, 2, 3, and 6. Let's do a couple more examples. Do a slightly bigger number, 65. I'm going to list out the factors of 65 going from the smallest to the largest. Now we remember that 1 is a factor of everything. 1 divides everything, so your list should always start with 1. And it should always end with the number itself. Okay, notice I'm kind of building them 2 at a time. Right up here, I said 1 divides into 6, and then I wrote the 6 at the end. 2 divides into 6 evenly, along with its companion factor of 3. 1 and 65. Okay, now we can see that 65 ends in a 5. Anything that ends in a 5 or a 0 is going to be divisible by 5. Okay, if you do the division, 5 times what gives you 65, you'll find that the other factor is 13. So 1, 5, 13, 65. Nothing else goes into 65 other than what I've listed right here. So there are 4 factors. Let me do one that has more factors. Let's say I was given the number 40. Okay, and I want to list out all the factors of 40 from least to greatest. Okay, so what I'm doing here is, well, same thing. I'm going to start with 1. I always start with 1. 1 and 40. Now I'm hoping I've left myself enough room here. There's a lot of things that go into 40. 2 and 20. Anything that ends in an even digit is divisible by 2. So if you end in 0, 2, 4, 6, or 8, you're divisible by 2. And what do you need to multiply by 2 to get 40? You need to multiply by 20. Okay, you got 4 and 10. 40 is divisible by 5 as well. 5 and 8, and I think I have exhausted all the factors of 40, right? The next biggest thing that goes into 40 is 8, and that's already on the list. So a neat trick for making a list of factors. I kind of start from both ends and work my way in. Okay, sometimes I have to erase to give myself a little more room, but that's okay. All right. So there are kind of special factors that we tend to look for a lot, and these are prime factors. Now, a prime number is kind of like the building blocks of numbers through multiplication. A prime number is divisible only by itself and 1. If you're talking about a prime number, there are only two things that divide this number, itself and 1. Quick note here, 1 is not a prime. Okay, examples of primes. 2 is the smallest prime. 3, 5, 7, 9 is not a prime. If I were to put 9 on this list, I would look at that and say, oh, 9 is 3 times 3. Not a prime. 10 is not a prime. 5 times 2 is 10. 11 is a prime. Okay, these numbers have no divisors other than themselves and 1. 13, another prime. 14, 15, and 16, not primes. 14 is even. Notice 2 is the only even prime. Everything else would be divisible by 2. Every other even number would be divisible by 2, so cannot be prime. Okay. 17, 19, 23. We can keep going on, but hopefully you get the idea. So every number is either a prime number or it can be expressed as the product of prime numbers. That's actually called the fundamental theorem of arithmetic. We'll just take it as a fact for right now. So every number is either a prime or it can be expressed as the product of primes. Okay, so let's look at some prime factorizations here. Okay. Okay, so what I want to do is express these numbers as the product of prime numbers. Okay, let's start with an example right here. Let's do 20. Now, we're talking about a little bit different kind of problem than what we were doing just a few minutes ago. A few minutes ago I was trying to find all the factors of a number that I was given. Here I'm looking for prime factors. So something that I find pretty useful when we're looking for prime factors is this setup here of a factor tree. Okay, 20 is even, so I know it's divisible by 2. It's 20 times 10. And now I work on breaking down 10. It's 2 times 5. Now none of these guys on the end can be broken down any further. They are prime numbers. So I have found the prime factors of 20. 2 times 2 times 5. Okay. Here's a pro tip. Use exponents for repeated factors. We'll look at more examples of using exponents in a second, but notice how the 2 is repeated. Okay, we would typically write 2 squared times 5. Okay, let's do a couple more. Prime factorings. Let's find the prime factors of 99. Okay, this is divisible by 9. As you can see, it's 9 times 11. 9 can be broken down a little further. It's 3 times 3. 11 cannot be broken down further. That is a prime. So we've found the prime factorization of 99. 3 times 3 times 11, or 3 squared times 11. Let's keep going. Let's do some more. 64. Okay. Anything that ends in an even number is divisible by 2. So that's divisible by 2. 2 times what is 64? It's 2 times 32. That's even. So we can break that up. That's 2 times 16. That's even. 2 times 8. That's even. 2 times 4. And that's even. 2 times 2. So look at that neat little chain that we got here. 1, 2, 3, 4, 5, 6. Now you can really see the usefulness of these exponents. 1, 2, 3, 4, 5, 6. Okay, notice how I'm counting there to make sure I'm writing the appropriate number of factors of 2. It's much easier to just use the exponent. The exponent is the count of the number of factors. There are 6 factors of 2 in this product. That's why we're using an exponent of 2 to express this. Okay. Now, you don't always need to use exponents when you're doing your prime factors here. Let me see here. This was the third example I looked at. Let me do a fourth example for you right here. Let's do 385. That ends in a 5. So I know it's divisible by 5. Over here I'm going to do a little long division and find out what the other factor is. Okay, so 7, 35, do the subtraction, 35 again, 7. So 5 times 77. Okay, building on what we already know. Now this breaks up 7 times 11. Okay, anytime you have a 2-digit number that's repeated, it's going to be divisible by 11. Okay, so 7 times 11 is 77, and now we've got the prime factors, because 5 can't be broken down any further into multiples, nor can 7. So 5 times 7 times 11, that's the prime factorization of 385. Okay, so exponents, using exponents. Exponents are used for repeated multiplication. Okay, so something like this. 5 to the 3. The number down here is your base. Okay, and this number up here, that's the exponent. Okay, the exponent tells you how many factors of the base you should put in your product. So the exponent tells you how many factors of the base to put in your product. So that expression I wrote down a second ago, 5 to the third power, 5 power 3. Now remember, when you're doing exponents, you've got to be conscientious about the positioning. An exponent should be written slightly smaller than the base, and it should be up off the baseline. Okay? So this indicates 5 times 5 times 5. Okay, the 3 is coming into play because we have 3 factors of 5 here. And if we do the arithmetic, 5 times 5 is 25. Multiply that by 5 and you get 125. Okay, so 5 cubed is 125. Let's do some quick examples of evaluating exponential expressions. Okay, so evaluate each. Let's do 2 to the 5th. Well, 1, 2, 3, 4, 5. 5 factors of 2. It's actually pretty quick to do something like this. Every time you multiply by 2, you're doubling. So take 2, double it, now you have 4. Double that, now you have 8. Double that, now you have 16. And finally double 16 and you get 32. So 2 power 5 is 32. Now you got to be careful what your base is and what your exponent is. If you switch those and say you did 5 to the 2, that would be 2 factors of 5 giving you 25. Okay, remember, the exponent is telling us the number of factors that we should have. So in this first example, 5 factors. 5 things multiplied together. What will we multiply together? A bunch of 2's. How many 2's? 5. 5 2's. This is 2 factors of 5. Okay? Big difference. Let's look at this here. 4 power 5. 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5 factors of 5. If you do the arithmetic, 4 times 4 is 16. Times 16 again is 64. Times 4 again, so 64, 128, okay, sorry, I lost count there. Okay, so we're doubling twice. Take 4, double it twice. So you got 8, you got 16. That gets us to here. So by the time we're here, we're at 16. Multiply that by 4. 16 times 4 is 64. Multiply that by 4. Now you're at 256. Okay? And then multiply 256 by 4, and we are at 1024. Okay? Things get pretty big pretty fast when you start dealing with exponents. Okay? So exponents do give us a convenient way to write down prime factors. So if I were going back here, right, and notice I was counting out there 1, 2, 3, 4, 5, 6, 6 factors of 2 to get to 64. Okay, so exponents are really helpful when we are looking for these prime factors. Okay, and there are some neat problems we can solve with these prime factors, and we'll look at that a little bit more as we go through the course. Okay, so I hope this gives you enough to get started on the homework for 1.7. Okay, make sure you're writing things up, showing me any work that needs to be done. Okay, remember, I'm grading your work. If you're just giving me answers, that's probably not going to be enough. There will be problems where you can, and I'll specify that in the instructions, but most of the time I am looking to see work. So make sure you're giving me the steps. You got to show me the reasoning behind how you're getting your answers.